Hi, welcome to Math 1127, Stat and Probability. This session is regarding discrete probabilities. So the discrete probability is essentially a probability distribution that specifically the x value are discrete. What does that mean? That means it cannot be a continuous variable. So for example, right, your height is continuous. Your income is continuous. Why? Because if you make, say, $60,000, you can make $60,001. It is a continuous variable because you can find a variable immediately before and after in between, right? Same thing with height. You can be 6'1", 6'2", but you can also be 6 foot of 5 and 8 inch or something. So there are many different ways to measure that. Discrete is specifically 1, 2, 3, -1, -2. It's got to be a whole number. So for example, one discrete probability would be what is the likelihood that you will see, let's just say, 2 cockroaches this week in your house, or less than 2, or more than 2, right? Cockroaches, you cannot see half a cockroach. I mean, I guess you can see half a cockroach, but it doesn't count, right? If you see 2 living cockroaches, right, or 3 or 5, you cannot see 1 1/4, right? So some of the exercise here, right? Let's look at this. This is the x value. So think about this is like how many cockroaches have you seen? Now I know they got negative, right? This is more like let's say you are like gambling or something. You know, you might lose money. That's all. That lose 6,000. Like, I don't know. But cockroaches, you have 6, 5, 4, 3, 2, right? And these are the probabilities. What does that mean? 20% of the time, you will get a -6 as your random variable, as your answer. 20% of the time, you get -5. Right? So this is very nice. Right? It's what we call uniform distribution. Everybody's the same. Very nice. So what is the expected value, E of x? And you're like, what is expected value? What does that mean? You just gotta understand this, right? E of x is simply the mean. In our case, it's the weighted mean. Why is it weighted? Because every single value that you have has a probability distributed, right, attached to it. So this is 20%, that's 20%. Okay, that's fair. But it may not always be the case. You might have a 40%, and this is 20%. You might have 0.5 and 0.1. So that's why you have to take that into consideration. Now, I could show you to do this by hand, but we should work smart. Let's try to use a calculator for this thing. So in order to put all this information into the TI-83 or 84 that you have, all you gotta do is go to Stat, say Edit, Enter. Now let me clear this off first. Forgot about that. So the deal is you want to use the list L1, L2 as your 2 different columns or rows that you have over here. So I'll go ahead and put -6, right? Enter, right? And then -5, -4, -3, -2, just like that. Then on the second column, I will just put in the probability, which is 0.2. All right, that's nice, 0.2 the whole way. And just want to let you guys know, you are allowed to put fractions if you want to. So if you want to put 1/10, you can do that. 1/5, you can do that. So now we got the L1 is my x, L2 is my probability of x. So let me hit second, quit, and go back to the main window. So how do we find a mean? Well, it turns out it's the same way you have done from the first unit. Basically, go to Stat, go to Calculate. You see the one variable stat. You can actually use this thing. Just hit Enter, and I have to tell them exactly what is my L1, like what is my x value, right? So I will just do second L1, comma, second L2. And then it will give you all this information. And we'll try to make sense of this thing. So now for those who have TI-84, with a more fancy TI-84, you may not need to do the F1, the L1, L2. They might give you a window that specifically asks you what is the X value, which you just put L1 there, and what is the probability that will be L2. A little bit more obvious, a bit easier to do, but it's the same idea. You'll get the same window in the end. So the first guy right here, see the X with the bar, that's your mean. Remember, that's always the mean, right? The sample mean. In our case is -4. So the answer is -4. It makes sense, right? All the probability are the same. So the middle guy will be the average, right? Now, when the probability are not the same, that's when you have to think. Find the variance. The good thing about this guy is they already give you all the information. So for variance, you see all this good stuff right here. But the variance, remember that, and in our case, I'm gonna use the population variance. It all depends, right? They might ask you for sample variance. So if they ask you for the population variance, you will have to use this guy right here, the sigma. Remember, sigma is the population variance. We are not going to have a sample in this case because it doesn't call for that one. It does not call for a sample when you have a probability already attached to them. So I'm going to do, but that might be different in a different problem, right? So we know the standard deviation in our case, right? Or maybe I should go to the bottom. The standard deviation for step 3 is 1.414. Or they want to round to one decimal place, so 1.4. Okay, we got that. But how do you find a variance? Remember, variance is the standard deviation square. So you just gotta do this. You just gotta do let me see if I can do like a equation here. 1.4 and square that. What does that equal to? Well, I'm gonna be lazy and just use this. 1.4 square, this is right here, and I get 1.96, which is roughly 2.0, right? Is that okay? 2.0 is 2, right? So you can put 2, it will still kind of correct. So there you go, the variance, the standard deviation. Step 4, find the value of P. So probability of X bigger than -6. This one is actually not too bad. What does that mean? That means they want to know what is the probability for everybody above -6, right? See, -6 right here is 0.2. They want everybody above that. So -5, -4, -3, -2. Add them all together. All these guys at the bottom, right? You see? Add all 4 of them together. So of course you will end up with 0.2, 0.2, 0.2, 0.2, right? Which is of course equal to 0.8, right? So 80% chances you will get above -6 in this particular distribution. So now, find the value of X less than -3. What? Right here's -3, right? You want everybody less than. Now, it's important not to count -3. Now, if they say less than or equal to, that's a different story. But now they just say less than, so we'll count these 3 guys. Of course, the answer will be 0.6, right? 60% chance. And that concludes the first problem. Now, let's go to the second one. Classify the following as either a discrete random variable or continuous. So that's kind of what we talked about earlier. The selling price of 131 randomly selected homes. That will be a continuous variable. Why is that? Because you might sell your home at, for example, $200,000 or $200,001. That can happen, right? You can sell for $1 above. So you can always find something just a little bit over, a little bit lower, right? It's a continuous variable. So not discrete. Discrete would be how many houses you have sold last year as a real estate agent. That's discrete. You cannot sell half a house, right? You gotta sell 1 or 2 or 3. Classify the following as either a discrete random variable or continuous. The weight of 89 newborn babies. Well, that of course is continuous, right? Weight has to be continuous. You can be 154 pounds or 154 point, I mean, not babies, of course, it could be, 8 pounds or 8.2 pounds, right, for example. Determine whether or not the distribution is a discrete probability or not. Now, there are several things you have to think about when it comes down to this thing. First, do they have the proper x value and the probability value? We do. But what is the key reason why it would be a probability distribution or not? You have to add these three together. So essentially, we'll add 3 over 8. Right, you can do that on a calculator. Plus 1 over 2 plus 1 over 8 to see if this guy equals 1. Yes. Why is that? Because you want the sum to be 100%, right? 100% is 1. If it's not 100%, if it's not 1, that means it's not complete. Then you cannot do it, right? So this guy is, since the probability, let me see, since the sum of the probability is equal to 1, that will be a yes. I know this is a little bit weird. So when you answer the question though on your software, just write yes, right? It's a probability distribution. Why? Because the sum of the probability equals 1. If it's not 1, there are different reasons here why it's not. So let's look at this guy. Let's try the same thing. This guy will do, let's see, 1 over 8 plus 1 over 8 plus 1 over 4. I got 0.5, so you know what's up, right? It's not equal 1. You only got 50% chance here. So it's incomplete. So the answer would be no. And why? Because the sum of the probability does not equal to 1, and we are out of luck for this problem. Let's look at number 6. Find the expected value for this thing. I believe you can do it. So go ahead and give it a try on the stat thing. So remember, stat, add it, and just change those two columns. And after you finish, go to stat, cal, one variable stat, and just do L1 comma L2. So give that a try and you should be able to get this one. Variance, same thing. Remember, you will get the variance. I'm sorry, you will get the standard deviation, right? Just like what we mentioned before, right? You get a standard deviation. You will have to square that in order to get the variance. Standard deviation, hey, that's easier. So now let's look at number 9.